In this lesson, we will continue to learn about solving exponential equations such as these. Please put your pencils down. Do not copy off of me. Learn how to do it from the video, but then give yourself the opportunity to see if you can remember it for 5 minutes and go back and do it yourself again. To solve this, first we have to get the exponential part by itself. So you would go ahead and add 6 to both sides. So that's going to give you 4 to the x power is equal to 10. Now we need to rewrite this in log form. Start with the base. So we will have log base 4. Now these two parts are going to change sides. So the 10 is going to be over here and the x will be over there. In order to evaluate this on the calculator, we will have to use the change of base formula. So this would be the same thing as log 10 over log 4. And you can just put this in your calculator. Okay. Log 10 over log 4. So log 10 over log 4. So let's go and do 2 decimal places, so 1.66. Alright, similarly on number 2 we have to get the exponential part by itself first. So we will subtract 1 from both sides, so e to the x equals 6. Now we will do log form, starting with the base. Alright, so this will be log base e, and these will switch sides. I'll have 6 here and equals x. You can skip this step if you want, because we would never really put log base e like this, because we know that base e is natural log. So instead of writing log base e of 6, we will just put natural log of 6 is equal to x. And we don't need a change of base formula then, because we can just do natural log of 6. Okay, so natural log of 6. So 1.79. Alright, take a look at number 3. The exponential part is already by itself, so I can just go ahead and write this in log form. Start with the base. So this will be log base 5. And the x and the 12 will change sides. So log base 5 of 12 is equal to x. Now this we will need our change of base formula, so this will be log 12 over log 5. And we will put this in our calculator. So 1.54. All right, so that's number 3. Number 4. All right, let's use a different strategy on this one because we have 2 exponential expressions. One way to do it, well, the easiest way, they already have like bases even. So if these bases are the same, then that means these exponents must be the same. So in other words, 2x must equal x plus 7. So you know, just subtract x from both sides, so that just gives you x equals 7. Okay, that was pretty easy. Now this one's more back to normal. Let us get the exponential part by itself first. So add 4 to both sides. So that'll give me 7 to the 2x minus 3 power is equal to 18. So using the change of base formula, no, not the change of base formula, rewriting this in log form, starting with base. So this is base 7, so log base 7. Okay, now these parts will change sides, so the 18 will be here and the 2x minus 3 will be there. Alright, now we have to go a little bit further because we're trying to get this x by itself. So we will have to add 3 to both sides and then divide by 2. Okay, so if I add 3 to both sides, okay, so I've got 2x. Now this, I'm not going to do 18 plus 3. I'm just going to put log base 7 of 18 plus 3 to stick it on the end. Alright, now we will divide both sides by 2. Alright, just make sure you divide the whole thing by 2. Okay, so that's going to get x by itself. Alright, so in terms of how you would put this in your calculator, you still have to do change of base here. So I'm going to have log 18 over log 7 plus 3. All that's the numerator. Then all of that is divided by 2. Alright, that's going to give me my x value. Okay, fine, so let's do that. Kind of an ugly expression, but it can be done. So what I want to do is start off in fraction mode. Now understand that this numerator is going to have to be everything you see here in the numerator. So right now my denominator is just 2. Boom. Now up here I need another fraction and then plus 3. So I will hit fraction mode again while in the numerator. So now I can type in log 18 over log 7. Alright, and I still need a plus 3 up here. So plus 3. So there it is, just like it looks on the paper. So 2.24. That's it. That's how you do number 5. Okay, number 6. Alright, first we have to get the exponential part by itself. Okay, it's just this part right here. So I got to get rid of this 3 in the front. So let's go ahead and divide by 3 on both sides. Okay, so that's going to give me e to the 3x power is equal to 4. Now it's time for log form. So this would be log base e. These two are going to change sides. So this would be log base e of 4 is equal to 3x. Now here again, you can feel free to skip this step right here and go straight to the next step because we would never really write log base e. Hopefully you know that log base e is better known as the natural log. So instead of writing log base e of 4, I can just put natural log 4 is equal to 3x. So you can skip this step and go straight to here. Now we still have to get x by itself, so we will divide both sides by 3. Okay, and that is going to give us our answer. We just got to put it in the calculator. Now using natural log avoids us having to do the change of base formula. Let me not put a box right. So in the calculator, so natural log of 4 over 3. So natural log of 4 over 3. So that's going to give us 0.46. Alright, fine and dandy. So that's number 6. Alright, let's find number 7. Okay, number 7. Now, I see that we have two exponential expressions. Anytime you have two exponential expressions, it's important that both of the bases be the same. So right now I have a 9 and a 3. It's really not working for me, but I can make these both into base 3. So here's what I mean by that. Well, the 3 is already base 3, so I'm just going to leave that alone. Alright, but 9. We know that 9 could be written as base 3 because 9 is 3 squared, right? So far I've just replaced the 9 with 3 squared. Now there's still this 2x here. Just put it in parentheses. Okay, so there's my 9 and then there's my 2x. So it's still 9 to the 2x power. But now the bases are the same. So understand that this would be 3 to the 4x power. 2 times 2x is 4x. Is equal to 3 to the 2x plus 4 power. Again, if the bases are the same, then the exponents must be the same. So that means 4x must equal 2x plus 4. Alright, to get x by itself, first we need to put these two terms together. So let's subtract the 2x from both sides. So that'll give me 2x equals 4. Now, finally, to get x by itself, we will just divide by 2. Alright, so that'll give us x equals 2. So that's how you do number 7. Now, number 8. Yeah, if I want to get the exponential part by itself, I'm going to have to subtract 1 from both sides. Okay, so that's going to give me 1/3 e to the x power equals 4. Now, I want to get rid of this 1/3. The easiest thing to do would be to multiply both sides by 3. That way these will cancel out, and just the 1, we don't even need to write it anymore. So we will just have e to the x power equals 12. If I rewrote this in log form, in my mind I'm thinking log base e. Okay, always start with the base, and then these are going to change sides. So log base e of 12 is equal to x. Feel free to skip this step because we will never write log base e. Instead, we will recognize that that is natural log. So this is the same as having natural log 12 is equal to x. And I can just put that straight in my calculator. Alright, natural log 12. So 2.48. Let's take a look at number 9. Do you have a pencil in your hand? If so, you need to put it away. Do not copy off of me. Learn from me, but go back and do the problem yourself, please. Okay, looking at number 9. Again, we have to get the exponential part by itself first, so we will subtract 4 from both sides. This is going to give us 3 to the x plus 1 power is equal to 4. When we rewrite this in log form, log, start with the base. The base is 3. Now these two parts are going to change sides. So we have log base 3 of 4 is equal to x plus 1. Then we have to still get x by itself by subtracting 1. So I'm going to have log base 3 of 4 minus 1 is equal to x. please note that we cannot go 4 minus 1 and just make this a 3. Alright, this log expression can't be split up like that. So, on the other hand, we need a way to put this in this calculator. We will use the change of base formula. Log base 3 of 4. That will have the same value as log 4 over log 3. And then we still got that minus 1. Alright, this can be put right in the TI-30XS multi-view. So, what did I say? Log 4 over log 3. And then minus 1. Okay, so that's 0.26. Okay. All right, looking at number 10. An initial investment of $250 keeps doubling over a 20-year period until it reaches $4,000. Then we have a bunch of questions. So this problem is a little bit different. We're not just going to be solving equations per se. Let's see what's happening. All right, how many times did the investment double? All right, look, guys, let's just make a little chart. Okay, let's make a little chart over here. So, initial investment of $250. Okay, wait, hold on. All right, so year 0. We had $250, okay? Maybe I should label this. So this is the year, and this is the value. Okay, so year 0, we're starting off with $250. Okay, 1 year later, we're at $500 because it's doubling. It keeps doubling. Well, hold on, I lied. Okay, you know what, so here's the deal. These aren't years. These are just how many times it's doubled. Okay? So we'll see how much time this turns out to be, but let's see, so what should I put here? Number of times. Alright, this is just the number of times that it doubles. So we start off at $250. If it doubles once, we're at $500. If it doubles twice, then we're at $1,000. If it doubles 3 times, then we're at $2,000. If it doubles a 4th time, we are at $4,000. Okay? So, it doubled 4 times and it reached $4,000. Okay? Look, it doubled 4 times, but it took 20 years. Alright, so it took 20 years. It said it keeps doubling over 20 years until it reaches $4,000. So it took 20 years. It doubled 4 times in 20 years. Okay, if it doubled 4 times in 20 years, how many years did it take to double each time? Well, 4 times 20 years, so if we do 20 divided by 4, okay, 20 divided by 4 is 5. Okay, that means for a total of 20 years, that means this must be 5 years, and then it must be another 5 years, and another 5 years, and another 5 years. Okay, 5, 10, 15, 20 years total. Okay, so it doubles every 5 years. That's what we are dealing with. Okay, so how many times did the investment double? Well, as you can see, it doubled 4 times. So 4. How often does the investment double? Well, as you can see, it's doubling every 5 years. Okay, how many times will the investment double in 35 years? Well, look, if it's doubling every 5 years, 35 divided by 5, okay, that means it will double 7 times. Okay, because I could keep going, all right? This is 5, we had 5, 10, 15, 20. If I kept going, 25, 30, 35, it would be at 7 times. All right, anyway, how much will the total be after 35 years? Oh, well, you know, whatever. I guess we'll just make more, we'll add on to the chart. Let's add on to the chart. Why am I changing colors? I don't know. You know what? I do want to change colors though. Okay, so if we continue on with the chart. Okay, so if it doubles a 5th time, okay, then that will be $8,000. If it doubles a 6th time, that is $16,000. If it doubles a 7th time, that is $32,000. Okay, and like I was saying, this would be another 5 years and another 5 years and another 5 years. Okay, so 5, 10, 15, 20, 25, 30, 35 years, double 7 times, the value is $32,000. Okay, how long did it take for the investment to reach $1,000? Well, let's look back at the chart. All right, 5, 10 years. Took 10 years to reach $1,000. Okay, how much will the total be after 17 years? Okay, this is going to take solving of an equation, okay? Because as far as a chart, we've got 5, 10, 15 years, 20 years, okay? So 17 years would be somewhere in between here. Okay, so how much will the total be after 17 years? It's going to be somewhere between $2,000 and $4,000. But what are we going to do? Guess? I think not. So let us set up and solve an equation. All right, let's start by figuring out what the equation must be. Now, we have everything we need, but nowhere in this problem did they say what the interest rate was. So that's the key. We're going to have to find that interest rate. Okay, so we know that the formula for an investment that's growing would be like this. All right, the amount is going to be that initial amount, and then it'll be 1 plus the rate to the power of time. Now, because we're talking about money, we could, I could have said it this way and said over n, and then n times t, all right, because this is what we do when we're talking about interest rates. But it doesn't say anything special like compounded daily or monthly or semi-annually or quarterly, nothing like that. So we're just going to be talking about annually, okay? So the annual interest rate. So we're talking about n equaling 1. And if n is 1, then we don't really need it, do we? So we will just be dealing with this. Now, the initial amount, we know what that is. Okay, that was $250. So that means 250 goes right there. Okay, 1 plus the rate. Okay, we do not know the rate. The eventual amount years later, that's what this y is. And we know that too. Okay, I mean, we know a bunch of them, but let's use the one that they gave us in the first place. Okay, we know that in 20 years is going to be $4,000. So let's use these two values. Okay, so $4,000 will be the eventual amount. Yeah, okay. So 4,000 goes here. And we know the time in this case, all right, because that's 20 years later. All right, so what we have to do is solve this equation for r. All right, and then we'll have the rate, and then we can make the equation and use it to find the 17. Okay, so how do we solve this equation? Well, this is what we've been working on, sort of. Let's divide both sides by 250. Okay, so that's going to go away. So 4,000 divided by 250. Okay, that's 16. Okay, so 16 is equal to 1 plus the rate to the 20th power. Okay, now I need to get r by itself. Okay, now if r were in the exponent, I would write this in log form. But the log form won't really help me on this problem, because I'd have, if I put this in log form, I would have log base 1 plus r. Okay, and then the 16 would go here, the 20 would be here. I would be no closer to solving this problem. So log form is not going to help me. But remember this, guys. For example, say if I had 16 is equal to n squared. How would I get n by itself? Okay, you guys know I would take the square root of both sides. Well, what if it was n to the 3rd power? All right, well then I would take the cube root of both sides, right? And that would get n by itself. Well, this is the same thing. Only I have something to the 20th power. So if I want to get rid of that, I need to do the 20th root to both sides. Okay, I'm going to do the 20th root on both sides. So that is going to give me, I have no idea what that's going to give me, but let's check it out. So let's practice that first of all. So the 20th root of 16. So in your calculator, we're going to wind up using this function right here, the x root. If I want to do the 20th root, I start with a 20, and then I hit second and choose that. So now I've got the 20th root. And we're supposed to be doing the 20th root of 16, right? Yes. Let's see what we got. Some crazy decimal, okay? Yeah, hang on to that in your mind. I really do not want you to round this, okay? So just leave that on your screen for a second. All right, so I've got this crazy decimal. So it's like 1.14, etc. Okay, So I've got 1.14 dot dot dot. I'm putting dot 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 because I don't want you to round it. And then that's going to equal 1 plus r. What's going to happen next? Well, if I want to get r by itself, then I'm going to subtract 1 from both sides. Minus 1, minus 1. So I'm going to have 1.14 dot dot dot. Actually, let's see. You should be able to do this in your head. If I subtract 1, this 1 is going away. So this is going to be 0.14, etc. is equal to r. Okay? Or if you didn't see that the subtracting 1 is just going to take away from that 1, with this number still on the screen, I can just do minus 1 like that. And see, I get 0. Blah blah blah. Okay. Let's see. What do I have here? Okay. So r is approximately. You write down. We really are going to need all of these decimals, okay? So 0.14869835. That's R. That's R. Okay? Okay, what can I do here? One more trick I want to show you to save you from writing down all of these numbers to solve the problem. We've never used this feature before, so it's time to learn something new. With this value still on your screen, I can store this value. See this button right here that says STO with an arrow? That's telling us that we can store this value in any letter that I want. So I hit that button. Now it's telling me where do I want to store it? Well, I will pick a variable. Now this is R, but R is not one of the choices, so I'll just use X. Okay, so if I do that and I hit enter, now that's telling me that this number is now entered for X, so we can use it. Okay. So now. Now I've got my equation, okay? So the equation, now that I have R, that means the equation is y equals 250, okay? Now we're supposed to do 1 plus R. You know, it was silly because I subtracted 1 from both sides, but I really want 1 plus r right here anyway, don't I? So I was about to have to add 1 back again. So I could have just left it 1 plus r. There was no need to subtract 1 from both sides. Okay, I can just take this and put it right here. So y is equal to, and it's to the t power. So that's 250 times 1.14869835 to the t power. Okay, we need all of those decimals. So you can write them down, or you can use the trick that I'm about to show you. Okay, so this is the formula. Okay, now, so I can now use this formula to figure out what's going to happen in 17 years. Okay, so I can go ahead and let this be, let t be 17. So I'm talking about 250 times 1.14, etc., to the 17 power. All right, so this is what I'm going to do. But as far as in the calculator, now I could sit here and type in all of those decimals, okay, if I wanted to. Or I could do this, 250 times times, okay, and I guess I had stored the decimal, so I have to do 1 plus r. So r, remember we put it in x, so I can just type the x now. Alright, and then that's to the 17th power. So bam! $2,639.02. That is the value after 17 years. Okay? Now that should be the same thing that we would have gotten if we had sat there and typed in all the decimals ourselves. Okay? If we had typed in, let's see, let's try it. 250, all right, times 1.1486983355 to the 17th power. Yeah, it's exactly the same thing. Okay, so you can either use my trick of using the storage feature, or you can just write out all the decimals. Some of you just will not understand the using of the store function, and it'll be easier for you just to write out all 9 decimals. Either way, make your answer. The one thing you cannot do is round it to 1.14. All right, if you round this, you're going to get the wrong answer. So do not round it. Use all 9 decimal places. All right, that is it. That is how you could do number 10. I hope this was helpful. I will see you on the next video.